Hey there, fellow circuit explorers. Ever wonder what makes your electronics tick? We're about to unlock the mystery of resistors, the unsung heroes of the electronics world. Get ready for a wild ride. These tiny components are like the traffic cops of circuits, making sure electricity flows just right. Without resistors, things could get chaotic. Imagine your LED lights burning out in a flash. So, buckle up as we dive into the world of resistors and discover how they bring order to the electrical jungle. Get ready to unleash your inner circuit builder. Okay, so what's the big deal about resistors? In a nutshell, they resist. They put the brakes on the flow of electricity, like a speed bump for electrons. Think of it like a water hose. A resistor is like squeezing the hose. It controls how much water or electricity gets through. The tighter the squeeze, the higher the resistance, and the less current flows. Resistors are essential for protecting delicate components and making sure your circuits work smoothly. They're like the guardians of the electronics realm, keeping everything in check. Now let's talk about the law of the land in the world of electricity, Ohm's law. This fundamental principle is the cornerstone of understanding how electrical circuits function. Just like traffic rules guide vehicles on the road, Ohm's law guides the flow of electricity through circuits. This fundamental rule helps us understand the relationship between voltage, current, and resistance. Imagine voltage as the force that pushes electrical charges through a conductor, much like how water pressure pushes water through pipes. Current, on the other hand, is the rate at which the electrical charges flow, similar to the flow rate of water. Don't worry, it's not as intimidating as it sounds. Think of resistance as the friction that opposes the flow of water in a pipe. In electrical terms, resistance is anything that impedes the flow of electric current, such as the material of the conductor or the components within the circuit. Voltage is like the pressure pushing electricity through a circuit. Just as higher water pressure can push more water through a pipe, higher voltage can push more electrical current through a conductor. This pressure is essential for the movement of electrons, which are the carriers of electric charge. Current is the flow of electricity, and resistance, well, you guessed it, it's the opposition to that flow. The higher the resistance, the harder it is for the current to flow, just like how a narrow pipe makes it harder for water to pass through. Ohm's law tells us that voltage, V, equals current I, multiplied by resistance, R, or V equals IR. This simple yet powerful equation allows us to calculate any one of these three variables if we know the other two. It's like having a map that shows us the way through the complex landscape of electrical circuits. This simple equation is like a magic key, unlocking the secrets of circuit behavior. By understanding Ohm's law, we can design and troubleshoot electrical systems with confidence. Whether you're a seasoned engineer or just starting to learn about electricity, this law is your guide to navigating the electrifying world of circuits. Resistors come in different flavors. We've got fixed resistors, the steadfast members of the resistance family. They have a set resistance value that never changes. Think of them as the reliable workhorses of circuits. And then we have variable resistors, the daredevils of the bunch. These resistors let you adjust the resistance like a volume knob on a stereo. They're perfect for controlling things like brightness, speed, and temperature. Whether it's a fixed resistor holding down the fort or a variable resistor adding some spice, these components are essential for fine-tuning your circuits. Section 5. Resistors in action, LEDs, timers, and sensors. In this section, we will explore how resistors play a crucial role in various electronic components and systems. From lighting up LEDs to creating precise timing intervals and converting physical quantities into electrical signals, resistors are the unsung heroes of the electronic world. Ready to see resistors in action? Let's dive into the fascinating world of electronics and discover how these tiny components make a big difference. Let's start with LEDs, those bright little lights that make our gadgets shine. LEDs, or light-emitting diodes, are everywhere, from our smartphones to our car headlights. But did you know that without resistors, these LEDs could easily burn out? Resistors are like bodyguards for LEDs, making sure they don't get too much current and burn out. They limit the amount of current that flows through the LED, ensuring it operates safely and efficiently. Without resistors, the delicate LEDs would be exposed to excessive current, leading to overheating and eventual failure. Next up, timers. Resistors team up with capacitors to create time delays in circuits. This combination is essential in various applications. from simple blinking lights to complex timing mechanisms in industrial machines. By carefully selecting the values of resistors and capacitors, engineers can design circuits that produce precise time intervals, crucial for synchronizing different parts of a system. Think of it like a slow-release valve, controlling the flow of electricity to create precise timing intervals. This slow-release mechanism is what allows devices like timers and oscillators to function accurately, providing the necessary delays and frequencies for various electronic operations. And let's not forget about sensors. Sensors are the eyes and ears of electronic systems, detecting changes in the environment and converting them into electrical signals that can be processed and analyzed. These clever devices rely on resistors to convert physical quantities like light, temperature, and pressure into electrical signals. For instance, a light sensor uses a resistor to measure the intensity of light and convert it into a corresponding electrical signal. Similarly, temperature sensors use resistors to detect changes in temperature and produce a voltage that reflects the temperature variation. Resistors help us sense the world around us. They are integral to the functioning of sensors, enabling us to monitor and measure various environmental parameters accurately. Whether it's a weather station measuring temperature and humidity, or a smart home device detecting motion, resistors play a vital role in ensuring these sensors work reliably and effectively. So the next time you see an LED light up, a timer counting down, or a sensor detecting changes, remember the humble resistor working behind the scenes to make it all possible. Section 7. Inside a resistor. Unraveling the mystery. Today, we embark on a fascinating journey to uncover the secrets hidden within one of the most fundamental components in electronics, the resistor. Ever wonder what's going on inside those colorful little resistors? These tiny components play a crucial role in controlling the flow of electrical current in countless devices. But what exactly makes them work? Let's peel back the layers and see what makes them tick. By understanding their inner structure, we can appreciate how they manage to regulate current so effectively. At the heart of a resistor lies a ceramic core like a tiny cylinder. This core provides a stable base for the other materials that will be added to it. Wrapped around this core is a conductive material, often made of carbon or metal film. This material is crucial because it determines how much resistance the resistor will provide. The type, thickness, and length of this material determine the resistance value. For instance, a thicker or longer piece of conductive material will generally result in higher resistance. It's like a recipe for resistance. Just as a chef carefully selects ingredients to create a dish, engineers choose specific materials and dimensions to achieve the desired resistance. And finally, the resistor is coded for protection and labeled with its resistance value. This coding not only protects the delicate internal components, but also helps in identifying the resistor's specifications. Now you know the secret inner workings of these mighty components. Resistors may be small, but their role in electronics is monumental. They ensure that our devices function smoothly by managing the flow of electrical current. So, the next time you see a resistor, you'll know just how much engineering and precision goes into making these tiny yet powerful components. Section 8. Don't get burned. The power of resistors. Hold on tight because we're about to talk power. Resistors aren't just about controlling current, they also deal with heat. When current flows through a resistor, it generates heat, like a tiny electric heater. That's where power rating comes in. It tells us how much heat a resistor can handle before it cries uncle and burns out. Choosing the right power rating for your circuit is crucial for preventing meltdowns. So, remember to factor in power dissipation when selecting resistors. It's better to be safe than sorry. Section 9. Resistor Roundup, your guide to circuit success. Congratulations, circuit champions! You've made it through the resistor boot camp. Now go forth and create amazing circuits armed with your newfound knowledge. Remember to choose the right resistor values and power ratings for your applications. And don't be afraid to experiment. That's how we learn and innovate. So keep those circuits humming and never underestimate the power of the mighty resistor.